This is chapter 6 in your text, and we're going to talk about nerves. Um, we're not going to get into as much of it in terms of quantitative as I wish we could. It's actually kind of complicated when you get into some of these equations, and they can't be solved analytically. You have to solve them computationally. So we're just going to talk at part. We're going to, and at times, we're just going to talk about them rather than having to work through some of these things. But there's still things you'll have to work through. And when we talk about nerves, nerves usually typically come in bundles, right? So you got a big bundle of nerves or axons, right? And each one of these is an individual cell that can be quite long. They get bundled together, and that is our nerve. If you've ever seen pictures of the peripheral nervous system, all separated out from the rest of the body, it's pretty interesting. Things we'll do in this chapter, we'll look at voltage and circuit concepts because we're talking about electrical signal propagation at some level. We'll look at the cable model of the axon. This is a model that's really just like the old telegraph propagation. So cable model of the axon, electrotonus or passive spread, a Hodgkin-Huxley model. Hodgkin-Huxley got this little thing called a Nobel Prize back in the day. We'll look at potassium conductance and sodium conductance. We'll look at how nerve cells are propagating nerve pulses happen, and then we'll look at the effect of myelinated fibers and saltatory conduction. Um, the axons are pretty much the same from nerve to nerve, but what determines a nerve's function is what happens at the ends of the axon, and whether or not it's myelinated. Myelinated axons, signal travels faster than it does in the unmyelinated one. And what happens on the ends of the nerves, the receptors and transmitters or transducer and synapses, these determine the function of a nerve. So you've got and you got to remember this is one cell, right? And the longest one in the human body typically is a sciatic nerve. And the sciatic nerve runs from your lower back all the way down your leg. So, about a meter, right? The ones that the ones that, um, uh, brain fart. The ones that Hodgkin Huxley used were out of a giant squid, and those are very long and they're very large. And that's the reason they use them because they're very large and you could actually manipulate them pretty easily. And rather than having to have, um, really fine tools. So this is, what happens here. There can be an electrical connection, there can be sensors, there can be a chemical exchange. All of this at the end kind of determines what happens. And how many nerves, it's not a one-to-one relationship. You can see here there are two nerves coming into this one nerve. Um, Very often it's not, and in the brain it's nowhere close to one-to-one. Um, it's not a one-to-one relationship. And so there are multiple pathways coming into each nerve, and each nerve lead or axon, each nerve cell leads out into more than one uh, receptor, right? So it's getting signals from more than one place and sending signals out to more than one place. This is kind of the secret of how our nervous system does such a great job. All right, that's it for this intro.